Okay, students, we're shifting gears. We're going to start on topic 7, which is working with different geometric shapes. And today we are going to be specifically working with parallelograms and rhombuses. Now, before we begin the lesson, I've got a piece of paper here, and there are two objects on this paper. They are both parallelograms. I want you to take a good look at them. They're both parallelograms, but one of them is specifically called a rhombus. And I need to know if you know which one is which before we ever begin this lesson. And I need you to know why they are called parallelograms. So we're going to, just for a minute or two, talk about the properties of what makes a parallelogram a parallelogram. Okay, so first of all, this one on the left is a parallelogram. P-A-R-A-L-L-E-L-O-G-R-A-M. So this is a parallelogram, and this is a parallelogram. Now, this is a parallelogram because it has two pair. Here's a pair, and here's a pair, and I'm putting tick marks on there. And those two tick marks, I'll better use my ink pen so you can see it. These two tick marks say that these match, and this one tick mark here and here say that the length of these two sides match. Okay? And there's something else about parallelograms. This little angle right here matches, it's the same size as this little angle right here. And this obtuse angle is the same size as this obtuse angle. Okay? Now if you look over here, well, this one looks like it's the same length as that one, and this one looks like, oh, it might be the same length as these. So there's the difference right there. All four sides of this one is the same length. This is a rhombus. And my favorite terminology for this is a squashed square. I'm going to put that in parentheses. S-Q-U-A-S-H-E-D, squashed square. You know, on a square, all sides are equal. And this square has been set on by an elephant or something and squashed it and angled it out. So a rhombus is like a squashed square. But they're both parallelograms. P-A-R-A-L-L-E-L-O-G-R-A-M. Parallelogram. This is a parallelogram and this is a parallelogram. This is a specific parallelogram. Now you notice that the opposite angles, this little one and this little one, this acute and this acute, look like they're the same size, and they are. And this obtuse and this obtuse are across from each other. They're called opposite. Here's a pair of opposite angles. Here's a pair of opposite angles. Opposite angles, opposite angles. Opposite angles are congruent. Remember, congruent means equal. Okay, so there you have the properties of a parallelogram. There's a few other properties that we're not going to go into right now. But it has two pair of congruent sides. So these match in length and these match in length. And on a rhombus, all four of them match in length. Okay, now that we remember what a parallelogram really is, let's start on today's lesson. In today's lesson, we're going to find the area. Remember, area is coverage, how much it covers. If I wanted to put carpet on it, or tile on it, or whatever, paint, anything. So, look at the solve and discuss on page 401. You're going to need pages 401 through 405, I believe. Yes. Alright, Sophia drew the grid below and plotted the points A, B, C, and D. She wants us to connect points A to B, B to C, C to D, and D to A. So I'm going to do that right quick. I'm going to do, and you should have rulers and you should be able to do this also. So we're going to connect A to B, and please do it with the pencil. I can't because you can't see my pencil on this view screen. I have to use ink. You should be using a pencil. B to C, C to D, and D back to A. Okay? Alright, so we did that. Now let's go back to our instructions. Then find the area of the shape. Okay, well that's easy. So the area of any square or rectangle is length times width, and you're supposed to already know that. Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That looks like 11. I'm just going to draw my picture over here. This looks like 11, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, down that way. And with my calculator, I'm going to punch in 11 times 19, and I get 209. So the area should be 11 times 19, so the area is 209. Okay? And let me see if I counted that right. Let's count one more time and make sure before we go any further. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that was 12. I wonder why they were giving us such odd numbers. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's a 12 by 19. So we do have a mistake. You should always check yourself. I get 228. 228. Well, what does that mean? That means if you count all these little squares, there would be 228 of them inside here. If you don't believe me, we'll go count them. Okay? All right. So we got that much done. Now let's see what they want us to do. Find the area of the shape and explain how you found it. Well, we did, and we made a mistake, so we had to go back and fix that. And that's okay. Everybody makes mistakes. And then using the same grid, move points B and C 4 units to the right. So take B and move it 1, 2, 3, 4 units to the right. And C 1, 2, 3, 4 units to the right. Connect the points to make a new parallelogram A, B, C, D. So then I'm going to put a B prime over here and a C prime. So they want us to move B. So here's what they want you to do. They want you to take from A to your new B. Draw a line. And from your D to your new C, and draw a line. And then, of course, we've got to extend this on over there for it to be a parallelogram. So we're neglecting that these points are here now. Now we're looking at, and I could even do that in a different color so you could see it. So now we're looking at, can you see that yellow? Yes, you can. Okay, so now we're looking at this. And we're not paying any attention to those other two blue lines. Okay? Now it says, what's the area of this shape? What's the area of this shape? What do you think it's going to be? So the area of this parallelogram now, that's that shape, what do you think it's going to be? Well, let's see. Does it look like this shaded, I'm going to shade this, does it look like this little shaded area that we took off of here and we moved over to here is the same size? Okay, so I agree it is. So isn't it going to have the same area? We took this piece of area off over here, but we put it over here. So it should have the same area. Okay? Now, what that tells us is that a parallelogram is going to have the same formula. So the area of the parallelogram is going to be a length times a width, but your length and your length can be this one, but your width is going to have to be perpendicular to this one. You understand what I just said? So this will be your length, but this right here will be your width. Your length and your width always have to be at right angles to each other. Always. Okay? So to answer the focus on math practices down here at the bottom, so on your focus on math practices, it says how can you find the area of any parallelogram, and we're going to put the same way you do for a rectangle. Area equals length times width. The length and the width have to be at 90 degrees to each other, at right angles. Okay, so we're going to draw a picture right here. If we call this the length, then we have to go find this perpendicular 90-degree distance to the length, and that will be our width. It won't be this slanted side. Okay, so please draw that picture there next to your formula. Okay, turn the page, and let's look at what they're saying for the area of the parallelogram. Look at the parallelogram below. If you move the triangle to the opposite side, then you form a rectangle. They're showing that we're going to cut this off, we're going to put it over here, we're going to slide it up there, and then it's going to form a rectangle. So that's why the formula is going to be the same for a parallelogram as it is for a rectangle. Alright? Then they go through the formula down here with you. The height of the parallelogram H, they call it H, instead of, they changed it, this is the width, so when we make it and move it over here, they called it the height. It's the same thing, which is perpendicular. You need to understand perpendicular means 90 degrees to the base. So if I call this the base, then this is my height. Okay? So, the area of the rectangle we've always said is the length times the width. Now we're going to say the area of the parallelogram is a base times a height, because there's a reason for this. You say, why are they changing letters? Well, there's a lot of formulas that have B's and H's in them, and the B and the H always have to be at right angles to each other. So, we could even say right here that the area of a rectangle is equal to the base times the height. Okay, so it's better to use the B and the H. Alright, so here's the formula we're going to use. The area of a rectangle is base times height, or the area of the parallelogram is base times height. Alright, come down here to the try. Find the area of the parallelogram. The area is B times H. The B is 7. The H is 4.5, 4.5. And then you can either do that by hand or you may use your calculator. And I get 31.5. So the area is 31.5 centimeters squared. Centimeters times centimeters is square centimeters. Okay? And then it has a convince me here that says compare the area of this parallelogram to the area of a rectangle with a length and a width. Again, you're going to multiply 7 times 4.5, so it's going to be the same. It will be the same. Has the same base and height, so it will be the same. Okay. Okay, let's go to example 2. Okay, so now we're going to find the area of a rhombus. The pendant at the right, a pendant is like a necklace, what's hanging at the bottom of the necklace. The pendant at the right is in the shape of a rhombus. A rhombus is a parallelogram with the sides of equal length. What's the area? Well, if we call this the base, then we got to come straight over here and go straight up to get the height. So the area is the base times the height. Or we could even do it inside here. Let me do this right here. We could go straight up from this corner, and we could have this dotted line inside the rhombus. Again, that would be 3. It can be put in here or out here, either one. So we're going to multiply the 3.8 times the 3 and get 11.4. Again, it's base times height. Okay, example 3. The area of the parallelogram is 72 meters squared. What's the height? Well, if we multiply these two to get that, then we're going to have to take that and divide it by one of my factors to get the other factor. So notice they start with their formula. They put the 72 in for the area, the 12 in for the base, and we're trying to find height. So we're going to divide both sides of this by 12 and get 6. So the height is 6. All you're doing is working backwards. A simple one-step equation. Okay, so over here, we're missing the base, but we have the height and we know the area. So we're going to put 135 in for the area. We're going to leave BB. The height is 15. So we have 15 times B equals 135. So we're going to divide by 15 to both sides. And that gives us a B of 9. The base is 9. Okay, one-step problems. Try it. Here we go. All right, on this one, we have a base and we have a height. So we start with our formula. Area equals base times height. So the area is going to be 20 millimeters times 22.5 millimeters. Go to my calculator and I'm going to punch in 20 times 22.5 and I get 450. My units are millimeters squared. Alright, on part B, area equals base times height. That's the formula for any parallelogram. So the area is 65, so I put 65 in there. I have a base of 13 times an h. So I'm going to divide by 13, divide by 13. Over here I get h. Remember those simple one-step equations? So 65 divided by 13 is 5. So it's 5 feet. If the units on the base was feet, the units on the height is going to be feet. All right. Turn your paper over. Goes through all of this one more time for you. Up at the top gives you a couple of good examples right here on this page. Let's go to the do you understand. How can you use the area formula of a rectangle to find the area formula of the parallelogram? Okay, remember what we did when we drew that? So here's what we're going to tell them. Just like we did in the solve and discuss. Remember when we did that? Solve and discuss? We're going to say that. Just like we did in the solve and discuss. Cut a triangle off one side, move it to the other side, and show that it becomes a rectangle. All right. Let's look at number 2. Ken combined a triangle and a trapezoid to make a parallelogram. If the area of the triangle is 12 inches squared and the area of the trapezoid is 24 inches squared, what is the area of the parallelogram? Well, we're going to add them together. So we're going to add, here's the area of the triangle. We're going to add it to the area of the trapezoid. And it's going to make a parallelogram. So that would be 36 inches squared. If you add inches squared to inches squared, you still have inches squared. You just have more of them. All right, let's go to number 3. Critique reasoning. A parallelogram is 3 meters long. We'll just draw us one. 3 meters long and 7 meters high. And I'm going to put me a little dotted line here. 7 meters high. Liam said that the parallelogram's area is greater than the area of a rectangle with the same dimensions. So we have area equals 3 times 7. So area equals 21 meters squared. So the area of the rectangle would be 3 times 7. So it's going to be 21 meters squared. Is he correct? No. They are the same. They are the same. Okay? Do you know how? Use the formula to find the area. Well, here we go. Always write your formula down first. So area is equal to 20 inches times 21.5 inches. Pick up your calculator, punch in the numbers. So area equals 430 inches squared. Okay, I'm assuming you can do 5 and 6, done the very same way. Number 7, a rhombus has an area of 440 meters squared and a base of 22. What's the height? Again, we're going to start with our formula, base times height. We're going to substitute 440 in for A. We're going to substitute 22 in for B and leave HH. We're going to divide both sides by 22 to solve for H. So H is going to be whatever 440 divided by 22 is. And that would be 20. Units would be meters. Just like one of the examples that we just went over. Okay. Your job for the remainder of class time is to do the practice and problem solving. You also need to finish 5 and 6 on this page and 8 through 15 on this page. Whatever your teacher asks of you, you have a vocabulary page that you really, really need to work on. And you have a quiz for this lesson if he or she chooses to give it to you. Okay, so you've got quite a bit of class time left. Let's work on parallelograms and rhombus, finding the area of parallelograms and rhombus. Okay, I'll see you next time.